area is given. So the sphere shown has a surface area of 95.03 meters squares. Find the radius to 2 decimal places, so nearest 100. This is what we call a backward problem. Because I'm given the surface area, so what I know is on the right-hand side, and what I'm trying to find, the radius, it's going to be part of the formula of the surface area for the sphere. I'm looking for the radius of that sphere. R equals what? Now, what is the formula of the sphere? Check your formula sheet and find the sphere, surface area of the sphere. Nope. Find more. Surface area of. That's right. That's right. So 4 pi r squared is how we calculate the surface area of the sphere. So notice again how our r, our unknown, is on the right-hand side, on the left-hand side of this equality, making this one a backwards problem. We have to calculate for it. So we have to undo all of the operations around r so we can figure out what r is. We call that in math very simply isolating for the variable, okay? Now what's around r? Well, first there's squaring and then there's times. And when you follow order of operations, you always have to do it backwards. So if I have times 4 pi, to cancel it, I will have to divide by 4 pi. Here it's going to be canceled. I'm going to be left with r squared equals 95.03 over 4 pi. And then I still have to do one more step to get to r. How do you cancel squaring? What's the operation that cancels squaring? Square rooting. So when you square root r squared, you just get r. And on the right-hand side, you just have to calculate using your calculator now. So this is the final calculation. Square root of, make sure you put a bracket here, divide by, you might need an extra bracket around the 4 pi, depending on your calculation. I think some calculators might be understanding the 4 pi together. I'm going to tell you what you should be getting, and then you'll know if you need extra brackets or not, okay? So you should be getting 2.7499. So I'm going to come around and see if you're getting that, and then we're going to round at the very end to the nearest 100. Notice how the final unit is meters now. We started with meters squared. This is meters squared because it was a surface area. It was a unit for area, right? Now, when we reduce it to r, the radius is a linear unit, right? It's not an area unit. So our final unit is meters now. Clear? Yeah. Where does the square come from? Well, because if I were to calculate, I would have to do r squared, right? So then the unit squares as well. So my unit's going to become m squared. Okay. So you have now a backwards question as well. Let's do some questions about surface area, but this time of composite shapes. Just like we have done composite shapes for 2-dimensional objects, we can do composite shapes for 3-dimensional objects. So imagine playing with blocks, wooden blocks. Remember when you were young and you played with wooden blocks and you made castles with those color blocks? Just put on, that's pretty much what it is, right? It's making a shape with those blocks. But then imagine gluing those blocks together in your finalized project. And now you have to paint your finalized project to kind of see what you've made. Wherever the paint gets to, that's the surface area of the composite object. meaning anything that you glue together, any overlap is not part of the surface area of the big object anymore. Now, what kind of overlap do we have in this figure of example 5? Here, in between the cylinder and in between the box, we're going to glue together. So now if I dip this in paint, those two circles, the one from the cylinder at the bottom and the one at the top that covers the box, right? Those ones have to be taken out of the calculation of the surface area. Imagine it. I'm going to just redraw it. I like drawing three-dimensional shapes. Inside lines that you cannot see, they're always drawn with dotted lines like this. Now imagine the cylinder now separately. Now, if I have to have the surface area of these two separate, obviously it's going to be bigger surface area than the ones together, because this circle at the bottom, it has to be out. And when I put it on top of the box, that's almost like a cutout, right? So you have to take out two circles out of the final surface area because they're covering up. Okay, so let's design a plan and then follow through with it. In step 1, we can do the surface area of the cylinder. In step 2, we can do the surface area of the prism, rectangular box. In step 3, we can calculate the surface area of any overlaps. And the final step, step 4, the total surface area, it's going to be 1 plus 2 minus 3. So we add the separate surface areas and we take away whatever is overlapping, and it's not going to be part of the area of the shape. That's one way of doing things, okay? One plan. I can do the same thing, but a little bit different, and we can talk about it another time. So let's execute the plan. Surface area of the cylinder. The formula for it is, okay, let me ask you so you can get practice finding these formulas in the formula sheets. So what's the formula for the surface area of a cylinder? Okay. Now, the 2 pi r squared, that's just the area of top and bottom circle, because the area of a circle is pi r squared, okay? And your cylinder has 2 circles, one at the top, one at the bottom, right? And this one, the 2 pi r h, is the lateral area of your cylinder. So the one that wraps around the cylinder. It just becomes a rectangle, basically, when you open it around, and the 2 pi r is the circumference of the circle, and the h is the height of the cylinder. So when I see the r and the h, that means I have to know what the r is for the cylinder, and I have to know what the height of the cylinder is. So what's the radius of the cylinder? 4. What's the height of the cylinder? 8, right? So all we have to do is just plug in and get the surface area. 2 times pi times 4 squared plus 2 times pi times 4 times 8. wants to tell us. Go ahead, Max. Okay, so how many decimals should we keep for an intermediate answer? Who remembers? What would be a good rule of thumb? You say 2. Anybody else? 3. The same person changes minds. Okay. I say 3. Okay, why 3? I agree with 3. At least 3. Why 3? Because they want the final answer to be rounded to the 10th. That's 1 decimal. You want to keep always at least 2 extra. So whatever other calculation you'll be doing, you're not going to round where your final rounding should be, okay? So good job, everyone. Let's keep going. Our second step is the surface area of the rectangular prism. Now for this one, we don't really have a formula, okay? We just have to imagine the netting, imagine all the sides of this box. And if they double up, then just double it because you don't want to do the same thing over and over, right? So we have a front and the back. The 14 by 12 is the front rectangle and the back rectangle of the back, right? So it's 2 of them. And inside the bracket, we have the area of that rectangle. What's the area of the rectangle? 14 times 12, right? Length times width. The front and the back. Length times width of that rectangle. Plus, let's do the left and the right rectangle. The left and the right rectangle. How many of them are there? 2. What's the area of one of them? Louder, Danica. 8 what? Just 8? It has to be an area, so it's a 2 dimension. So 8 times what? 8 times 8. 8 times 12, right? 8 times 12, the left and right. Make sense? Yeah, we're doing the left and right. That's what I was thinking of. Okay. And then plus 2 times. Now top and bottom is the one that I did last. Top 14 by 8. That's right. So 2 times 14 times 8. Top and bottom. So this was front, back, front and back. But that's for 14 and 12, so don't get confused, right? So this calculation are for the squares are front and back. Okay, maybe I'll put it aside here. So this calculation is for the left slash right. And this calculation was for top slash bottom. Okay, so let's see what we get for the surface area of the box. Perfect, yes. Now at 3, for some question, you do this. You're going to think about the overlap, okay? In some question, actually, it's really easy to leave out the parts that are overlapping, right? So with the way we analyze it here, I know that I'm going to have to take out 1 circle from here and 1 circle from there, because when you glue them together, that area disappears, right? From 2 parts that before they were there. So since the surface area of the cylinder has this 2 of the pi r squared, 2 of those circles, I could have just left that out. And then at this point in time, all I have to do is just add my answers because I already thought about the overlap to begin with. So you can approach the question like that as well, thinking about what's overlapping and then just leave it out of the initial calculation. Because we're still trying to understand why we have to take something out. So we're going to do the overlapping separately, okay? So how many circles are overlapping? No, when you overlap something, there's always, it's just like making a sandwich all the time. There's always going to be 2 parts, right? So 1 from the cylinder at the top, but it covers the same area on top of the box. So in the end, 2 of those circles have to be taken out. 1 from the bottom of the cylinder and 1 from the top of the box. Did I say that again? I did say that, right? 3 times, 4 times? Okay, so make sure that it's understood. You always have to take 2, depending on the question, but this one, yes, they're glued together. So 2 times the area of the circle is the overlap. So 2 times, what's the area of the circle? Pi r squared. R is the radius of the circle. So 2 times pi times 4 squared. A 101. 5, 3, 0, dot, right? So 3 decimals is okay. So now we're gonna put it all together. Remember the plan. Total surface area is add the first 2, subtract the overlaps. So we're gonna add to 301.592. We're gonna add 752. We can make this one in a 3 if we round. And then minus the 100.530. That's my point there. It's 100. What are we getting? Point. Can I get a couple decimals? So approximately 953.1. What's the unit for a surface area? Yeah, feet squared. All good? Okay. A little question, but this time has a story around it, okay? These ones are, or this is a cake made of 2 other round cakes. So 2 round cakes are arranged as shown in the diagram below, and they're covered in icing. Calculate the surface area covered with icing, and there's a note there. There's usually no icing on the bottom of the cake. Okay, usually when you put a cake, you just smudge a little bit of icing so it glues together to the bottom, but you don't really cover the entire thing in icing. Okay, does that make sense? So what does that mean for us? Because we only have to calculate the surface area that includes icing. With the inward circle here, the space between the top and the bottom layer, with those circles have icing? No. They could, but they won't. Okay, they could. You could cover the first one in icing and then, you know, yeah, and then put it on top, right? So you can definitely interpret it like that, but make a note that you're special. You know, you put the icing differently. But usually in bakery, you wouldn't put the icing over there. You would just arrange your cakes in the shape that you want to make your cake, and then you just cover with the icing at the very end, right? So you only put the icing on the outside of your cake. Okay, but yeah, you're right. You could if you want to. If you're making it at home and you like more icing, that's right. You just put more icing, right? So over here we don't have icing, and also it tells us that the bottom part, which is the big circle at the bottom, that also doesn't have any ice. So I would approach this question by excluding from the very beginning the part that I don't want. And I want you to see an example of that as well. So we can still design a plan, but in this situation, we're going to take out the overlaps from the beginning. So not at the very end, right? So The plan is going to be as following. Step number 1 is surface area of the little or small cylinder without 2 circles. Because the same circle, it's going to cover the same circle at the bottom of the big cylinder, right? So it's the same type of circle. And then step number 2 is going to be surface area of the large cylinder without what? Yeah, so how many of them? One. Because, on the table, I don't really have anything anymore, so I don't have to double it. There's no more sandwich on the table, right? So it's only the circle at the bottom of the big cylinder that has to be removed. Make sense? Okay. So, okay, how does our formula look like when we remove 2 little circles? Your original formula of the surface area of a cylinder looks like this. 2 pi r squared plus 2 pi r h. This first section, those are your circles. This is the circle. So if I want to remove 2 circles, I don't even have to include it in my calculation. I can just exclude it altogether. And I'm going to get those overlaps out from the beginning. Surface area of the large cylinder, again, how does it look like? Well, it just means that I have the same formula, 2 pi r. I'm going to write the r with capitals so we can distinguish between the 2 cylinder. R squared plus 2 pi r h. Now I only want to remove 1 circle. This is the part of the formula that has the circles in it. So if I don't want 2 of them anymore, how do I change the formula? That's right. So basically you have a 1 there, but if you just get rid of it, that's what it means. 1 times that is still that, okay, 1 of them. So 1 in front of it, or just ignore 1 altogether because it's still 1 of them, even if you don't write them. Okay? And then just formula already includes that removal of the circle. And at the end, step number 3, we're just going to add these and I'll get our final answer. So let's apply. The little r is what? 14 is the diameter divided by 2, 7. What's the h? 5. So now what we have to do, surface area, is going to be 2 pi times 7 times 5 equals. Shout out. 9. 219.911. Step 2, we want big R, big H. Big R is going to be half of the radius, so 13. And H is the same, right? 5. So we have pi times 13 squared plus 2 times pi times 13 times 5 equals. Step 3, total surface area. 219.911 plus 939.336. Can we get? I wish I could see so far. I can't see over here.
1,159.2.7.
So let's keep one decimal for this one. This question doesn't tell us where to round, so we will, assuming we're gonna round a 10th because we kept on keeping 3 decimals. So approximately 1159.2. What's the unit for this? Centimeters squared. Everybody good? Which one? I can see there's some question there, but I didn't hear it. Which one?
The answer, the
470. Yeah. Okay, so I want to show you this, but if you like the previous method, if you want to make it a picture of this, feel free to. You can still approach this question the same way we approached the previous, right? So you can do the small cylinder, the large cylinder, then the overlaps, small cylinder, large cylinder, and at the end design a plan, which you're gonna have to take out, right? So you add the first 2, take out 2 of the small circles and take out 1 of the large circles, right? The same answer, it's just a different approach. All you gotta understand is that you cannot include the whole thing of the 2 separate. It's kind of like when we've done set theory and we had the overlapping circles, and we had to calculate sometimes the number of, right, for the total. And if you had overlapping, those overlaps cannot be counted twice, right? Same idea, you have overlapping here, you cannot count them all together in this situation because they're hidden, they're glued together. Okay, so moving on to, let's take a break. It's 6:42. Let's stop and begin with volume at 7. Moving into calculations of volume. There's 2 kinds of calculations for this idea of volume. One is volume and one is called capacity. Again, back in the days that you did both of these, maybe in grade 7, you did question with both of them. Volume refers to how much space a certain object takes in this room, for example. And capacity is how much volume it contains. And because every single object is made of some material, the difference between the volume and capacity is a little bit because that material takes some space too, right? So you cannot fill in a certain cup with the amount of volume the cup is, okay? Because you can only fill what goes inside, okay? So you can't fill the walls of it. But for our purposes in this class, we're not going to make the differentiation. So whatever volume it is volume. You don't think about capacity and volume separately. But I want you to understand they're 2 different things. The volume is going to be a 3-dimensional calculation. So when you're working with units and you have to report units, make sure all your units are cubic this time, okay? So cubic units for all volume calculations.